So, good morning, everyone, and welcome to today's class. This is lecture number 24 in Work by Energy, and we are discussing this particular topic in great details because it is one of the most important topics, easier one at that level, and we can always expect at least one or two questions coming straight away from this chapter or one or two more questions which apply the concept of work, power, and energy. It's easy for you to understand this that there are some concepts in physics that are not only applicable in that chapter, but it is applicable in the entire physics, the physics that you are going to learn. And this work energy theorem or law of conservation of energy, as you would realize in the chapter of gravitation or in the chapter of SHM or in electrostatics or even in your nuclear physics, the modern physics, you will be requiring all these concepts of work energy theorem or law of conservation of energy. In collision, you will be requiring it. In entire mechanics, you will be requiring it, no doubt about that. Work power energy, the work energy theorem, law of conservation of momentum, which will come in the next chapter, law of conservation of angular momentum. All these things are applicable everywhere, and therefore it becomes important for us to understand these topics in great detail. Think someone has unmuted himself. No. Okay. So it becomes important for us to understand this topic in great details, and that is why we have been insisting so much on these topics. In the last class, we had discussed some questions based on the work energy theorem, and if I just recap, there was a question that right now on your screens taken from your last class, where you had a block and this block was kept on the top of a hill and it was supposed to compress the spring on the other side, and we were supposed to find out the maximum compression in the spring. That was the last question I think that we discussed, or we discussed any other question after that. I think that was the last question that we discussed, or did we discuss any other question? Please let me know. That was the last question. Okay, I got a reply. That is the last question, sir. Okay, Vahini, thanks for letting me know. I have a very short memory, so I tend to forget things what I have done in the last class, and that is why I keep on asking you. So that was the last question, as Vahini has said. So there is one more question that we should discuss over here, and let us start with that question. It's the same question, but there is a small what should I say, twist or whatever you call it. So I will discuss that question as well. So right now I've just changed the scenario a bit. I have a spring of spring constant K, as you can all see. Not a problem. This is a spring of spring constant K. Now at the top of this spring, at a height h, from the top of this spring at a height h, I have put a block of mass m, and obviously this block of mass m is at rest. I'm holding it. Okay. The question seems pretty simple. What is going to happen is I'm going to drop this. When I drop this, it is going to fall on the spring, and we'll not assume that it will bounce back. So it will not bounce back. It will fall on the spring and it will start to compress the spring. I hope you all understand this. So this block will fall on the spring and it will try to compress the spring. The spring will keep on compressing, the ball block will keep on falling, and at one point in time something will happen. What is that something? The spring will have its maximum compression. That is what you need to find out. Find the maximum compression in the spring. Find X max. And what is this X max? This X max is the maximum compression in the spring. That is the question. This question is, all the questions in work by energy are similar to each other. We just need to apply the same concept. And the concept is very simple. There is the only forces working here are gravity and spring force. Both are conservative. So instead of applying work energy theorem, we can do this problem by applying LOCME, law of conservation of mechanical energy. I'll give you 2 minutes. Can you tell me how this question is done and what is the answer for this particular question? 2 minutes is what you are going to get for this. I'll keep my mouth shut. I hope question is clear to all. Block of mass M at a height h, spring is down, falls, compresses the spring. What is the maximum compression in the spring? Anyone there with an answer? How it is to be done? Waiting for your responses. Are you trying, everyone, this question? All the participants, can you raise your hands so that I know that you are trying the question? Vaini, Tarun, well done. What about the others? Okay, wow, wow, wow. Good, good. 8 of you have raised your hand. 9. What about the others? Swati, okay, 10. Okay, Jagdish, Kevin, Kushi, Krishna, great. Sai, Satya, Satya, good. Your emoji is good. I mean, that DP is good. Pavan, Kalyan, Krishna, Kushi, Karthik, Kevin, Deepak. You're all there in the class, right? Well done. Anyone would like to let me know how it is to be done? Vaini is saying half kx square. Vaini, what is half kx square? What is x here? I'm asking you a question. You are giving me the answer in terms of something that I don't know. That cannot be the answer. So that is not correct. What are the known things here? The known things here are k, h, and m. So whatever your answer is should be coming in terms of these three quantities. Then only it's an answer. If it is coming in terms of any other quantity, that is not an answer. That is in fact a question in itself. Okay, keep on trying. I'll give you 1 more minute to think about it. It's pretty damn simple. It's pretty damn simple. I hope you are able to solve it. Sorry. Shall I give you a hint? The hint is very simple. Number 1 is apply LOCME. Number 2, at maximum compression of the spring. When the spring is compressed to its maximum, what will happen to the velocity of the block? When this block is falling, its velocity will keep on increasing. Its velocity will keep on increasing. Up till what point will the velocity increase? As soon as before it hits the spring, the velocity will keep on increasing. After that point, it will start to compress. Yes, Vahini, it will start to compress the spring and the velocity will start to decrease. At maximum compression, the velocity of the block is going to be 0. I can break this question into 3 points, into 3 different positions. This is position number A, where the block is initially. This is position number B, when the block is about to hit the spring. And then I have this position number C. And in this position, the spring has been compressed by the maximum amount, which is H max. So I can break this question into 3 different points. Point A, initial position. Point B, it is about to hit the spring. Point C, the spring is in its maximum compressed state. And at this state, when the spring is at its maximum compression, point C, the velocity of the block is going to be maximum. Oh, velocity of the block is going to be 0. Can anyone tell me what happens at point B? If I talk about point B, what will be the velocity of the block? That is a sub question that I can put here. What is the velocity of block at point B? Will it be maximum velocity that the block has, or will it be something else? That question ka answer you can give me. At point B, what will happen to the velocity of the block? Will it be maximum or will it be minimum? Vahini says minimum. Vahini, that is not correct. That is not correct. Hanak says velocity becomes 0. So probably Hanak is talking about the point when the spring is in its maximum compressed state. Yes, at point C, Hanak, the velocity is 0. And at point B, now Vahini has corrected herself. The velocity of the block is definitely maximum. It will reach its maximum velocity when it reaches point B, which is the green point. If I come back to my initial point, point A, the velocity of the block at this point A is very evidently equal to 0. So I have told you everything that you need to know or you need to remember to solve this question. I'll still give you a minute. Why I'm giving you so much of time? Because I want you to do this question on your own. I can do it in 1 minute, now not a problem, but I want you to do it so that you understand what all things are required here. So 1 more minute to solve this question. Anyone would like to say anything about this? Any thought? No one? Okay. Now is the time that I let you know how this question has to be done. Now remember, in this question, the only thing that has been asked is to find out the maximum compression in the spring. So let me first solve that part and then I will solve the sub question. The sub question is what is the maximum velocity or velocity at point B, which is pretty damn simple. We will be solving it. But let us first concentrate on the main question, and the main question is to find the value of H max. To find the value of H max, what I'm going to do? Well, I don't have a magic wand. I'm just simply going to apply our old friend LOCME from the initial point A to the fired point C. Now you might wonder, you might ask me, sir, can we not apply LOCME from A to B? Yes. Yes. We can apply LOCME from A to B, and from that equation, from that concept, we will get the value of maximum velocity at point B. We can get the value of maximum velocity at point B by applying LOCME from A to B. But here I don't want to do that in the first place. I am supposed to be finding out the maximum compression in the spring. So I will attack that question first. I'll apply LOCME straight away from point A, which is the highest point, to point C. And if we just keep our concentrations high, we should be able to avoid the stupid mistake, which is the mistake that most of the students do in this question. We need to avoid it. So what I'm going to do is I'm going to find the mechanical energy at point A, and then I am going to equate it with mechanical energy at point C. Now the question is, what all mechanical energies? What is the mechanical energy at point A? Now at point A, it consists of three types of energies. One is kinetic energy. Another is gravitational potential energy. Then the third one is spring potential energy. But as you can see, at point A, there is no spring. Right? I can just neglect the spring potential energy. So basically, I'm concerned with two energies here. One is kinetic energy at point kinetic energy at point A, and the second one is potential energy at point A. To find out potential energy, which is gravitational potential energy at point A, I have to find out a point whose energy can be taken as 0. Now that point can be anywhere. That point even can be point A. But as I have always told you, I never take the highest point as the energy 0 point. I always take the lowest point. That is how I have done questions in my life. So what I'm going to do, the lowest point is point C. As you can all see. The lowest point is point C. So I can write the gravitational potential energy of this point as 0. Do we understand this? C is the lowest point, and I am taking the energy, gravitational potential energy of point C as 0. Can I have some reason that we understand this? So gravitational potential energy of point C, which is the lowest point, is taken as 0. Then I can find out the gravitational potential energy of point A. What will be the gravitational potential energy of point A then? Can anyone tell me that? What is the value? Vahini, it is not maximum or minimum that I'm asking. It is definitely maximum. What is the value of gravitational potential energy of point C, of point A? mg into h plus x. That is absolutely correct, Hanak. And this is the most important point in this chapter, in this question, Santosh, that it is mg h plus x. Most of the students, they do a mistake, and instead of writing it as mg into h plus x, they write it as mg into h. Because somehow in solving the question, they forget that x should also be added. This x, the amount by which the spring has got compressed, needs to be added as well. So the gravitational potential energy of point A becomes mg h plus x, and this is what we are going to write. The gravitational potential energy of point A, let me take this out. Strong. Okay. The gravitational potential energy of point A is mg h plus x plus, let us talk about the kinetic energy at point A, and it is definitely at rest, so this is equal to 0. So that is one part of the equation, mg h plus x plus 0. Let us talk about the mechanical energy at point C, which is the yellow part. Now at point C, I have two types of mechanical energies. At point C, I have mechanical energy which has two types of potential energies. One is the gravitational potential energy, which is zero. What is the other type of potential energy that I have here at point C? At point C, do I have any other type of potential energy? Yes, Anag, we have spring potential energy also. What is the spring potential energy at point C? Anyone? Yes, Teja. How much is the value of spring potential energy at point C? Remember, at point C, the spring has been compressed by the maximum amount, half H max. We call it H max. Let us not write it H max. Let us write it as X, so that don't have to write so much. What is the spring potential energy at point C? No one knows it. The spring has been compressed by an amount X. What is the spring potential energy? Yes, it is half kx square, Hannah. Half kx square. Remember, it is always positive. It is never negative. So spring potential energy is half kx square. Gravitational potential energy is zero. That is why I'm going to write 0 plus half kx square. This is the potential energy. What about the kinetic energy at point C? At point C, it is again coming to rest. So the kinetic energy is also zero. So remember, this zero is for gravitational potential energy. This half kx square is for spring potential energy. This zero is for velocity becoming zero. So that is the kinetic energy wala part. Do we understand this? Can I have some reason that we understand this? 1 0 is for gravitational potential energy, 1 0 is for kinetic energy, and the third part, half kx square, is for spring potential energy. And well, that is our answer. We can just solve this equation, write it in a form. So how I'm going to write it? I will write it as strong color. I'll write it as kx square minus 2mgx minus 2mgh. So I've taken 2 on that side, and then I've removed all these on one side. This is equal to 0. Now this is a quadratic equation which I am not going to solve. I will leave for you to solve this. This is a quadratic equation that will give me two values of x. One will be negative, the other one will be positive. We will be taking the positive value and we will be getting our answers from that. If I solve this equation in this form, it will look a bit difficult for you. But if values are given and good values are given, you will get a definite answer from this equation. So solving this equation, you should be able to get your answers for the value of x. Do we understand this? Can I have some reason that we understand this, sir? Okay, great. I hope everyone understands this, right? I'll give you a minute to note down this solution. If you have any doubts, you can type your doubts or you can ask me. I will unmute you. Then you can ask your doubts on your microphone as well. 1 minute to note this down. Well, I hope all of you have noted down the solution. It is pretty damn simple. Now, in this question, there are a few things that can be done. What are those few things that can be done? Now, this question could have a condition given to you. What condition? Let me just elaborate on that condition. This question can have a condition given to you. So, the condition is like this. And I'm giving the condition. If it is given that this h is very, very, very large compared to x, that means this block is very high up and this spring is very stiff. Think about a spring of uh, train ka dabba, coach of a train. It is very hard spring, stiff spring. Even if I put a lot of power, lot of energy, lot of weight, it will hardly compress. It will compress very minutely. So if this is the spring of a train ka dabba, train ka coach, if I drop a small block from the top, the spring will hardly compress. It will compress very less. If that is given to you, that spring ka compression is going to be very, very less. Remember, condition. If the compression in the spring is going to be very, 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 very less, then what you can do is, if I compare these two terms, then what are what these two terms? This term and this term. If I compare these two terms, if x is very, 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 very small compared to h, I can neglect this term completely. So basically, when I'm saying that I'm neglecting one term completely, basically what I'm going to say that this equation, which is the correct equation, I'm going to write this correct equation in a different way. I'm going to write this equation in this way, that the total energy, which is potential energy at point A, is only mgh. I've neglected x because x is very small. So total energy at point A becomes mgh. Total energy at point B becomes half kx square. In this case, the answer becomes pretty simple. The answer becomes x is equal to 2 mgh by k ka under root. Now this is the answer that most of the students will mark if this question comes in the form of an objective, and it will only come in the form of an objective. One of the options in that objective would always be this. One of the options will always be this. Don't mark it straight away. This is the answer only when we are neglecting x compared to h. X is very, very small compared to x. Then we will get this answer. Otherwise, our answer will not be ever this much. So that is one thing that most of the students do a mistake. As I told you, this question comes and students do a mistake. They don't solve this entire equation. They just write this part because that part is already there in the answer, and you just see total energy at this point is mgh. Total energy at the lowest point is half kx squared. They just equate these two terms and get the value of x straight away. Remember, that is not the correct answer. That is the correct answer only when we are neglecting x with respect to h. Do we understand this? Can I have some raised hand that we understand this? What is the common misconcept or common mistake in this question, and why is that mistake, and how that mistake can become the correct answer if the assumption is given? What about the others who have not raised hand? Vijay, Tarun, Harshita, Swati, Surendra, Shreya, Satvika, Sai, Reddy, Kevin, Karthik, Jagdish, Satya. Are we all there on the same page? Great. One more substitute question that I can ask here in this question is, what is the value of velocity at point B, which is the question that we are going to answer now. I'm expecting an answer of this question from you guys. This V is put as question mark. You have to tell me what is the value of this V. Velocity at point B. I will give you 1 minute to tell me another question in this question. What is the value of V? The velocity with which it strikes. The velocity with which it strikes the spring. 1 minute. I hope I can get an answer in 1 minute. Viney saying half mg h plus x. Viney, what is x here? If you are giving an answer in terms of an unknown quantity, remember, bacha, that is not an answer. That is a question in itself. That is a question in itself. The only known quantities in this question are m, h, and k. If your answer is not coming in terms of m, h, and k, it has to be wrong, because then that is not your answer. It is a question that you are asking. So, Viney, think again. What is the value of v? Velocity at point B. Anyone with an answer? Velocity at point B. Anyone has this answer? Are we trying, everyone? No one is trying? Can I have raised hand that we are trying, sir? Trial is important, answers are not. I've always insisted on that. If you're not trying, that is a problem. If you're not getting an answer, that is not a problem. That is not a problem. But if you're not trying, then it's a problem. Only 11 students are trying. That is not a good sign. What about the others who are not trying? Wine is trying, but she has not raised hand. So there are some students who are trying but not raising their hands. Okay. Okay. Concentrate on solving the question rather than raising your hands. I have faith that you are trying the question. Anyone with an answer? That is the next part. I'll give you a minute. I'll give you a minute to give me the answer. One more minute. What is the velocity at point B, which is the point where the block strikes the spring? Hanak is again giving me answer in terms of an unknown quantity. Hanak, x is an unknown quantity. The answer cannot come in terms of an unknown quantity. Is this thing very difficult for you to understand? That an answer cannot come in terms of unknown quantity. Please remember this. If you don't understand this, well, think again. If you again don't understand this, again think again. If you don't understand again think again. The only known quantities in this question are m, h, k, and you can use g, the value of acceleration due to gravity. If you are getting any other quantity as answer in your question, that is absolutely wrong. May not be wrong. You're asking me a question. You can't ask me a question. If I ask you a question, you can't give the answer in the form of a question unless it's a doubt. Vine is saying MGH. Vine, the dimensions are wrong. There are two basic things that you must understand whenever you are getting an answer. The first is it in terms of the known quantities? Viney's answer is in terms of known quantities. M is known, G is known, H is known. Second, and the most important thing, that is the first thing that we learned when I started class 11, does it have the same dimension? MGH does not have the dimension of velocity. So that answer cannot be correct. MGH has the dimension of energy. Vine is giving me the answer of energy. Vine is telling me MGH is the velocity. How can MGH be the velocity when MGH is the potential energy? Your answers cannot be like this, because this is absolutely rubbish, and this rubbish cannot be tolerated at this point in time. I'm asking you velocity and you are telling me the answer in terms of energy. That is not tolerable at this point in time. Nope. No. No. Cannot be done. Cannot be done, Vahini. Understand this. Cannot be done. Uh, Sorry, I got disconnected. The power has gone at my place. Am I audible and visible to all of you? I mean, I'm not visible. I've switched off my camera. Can you all hear me and see my screen? Yes, Anak. Okay. So it's all dark here, so I'm not using my camera, and I hope you can see the screen. Okay. So I've asked you the velocity at point B, Vijay. Any answers? Remember, two things must be there in your answer. It must be having only the known quantities, and Vahini, it cannot be in the wrong dimension. If it is in the wrong dimension, that is absolutely not the answer. The first thing that you check about your answer is the dimension. MGH is the dimension of MGH is energy, cannot be velocity. I've asked you velocity. So anyone with an answer? Okay, the light has come, so I'll put on the camera. The camera is on. Vani, don't be sorry. I just had to make a point, and that is why I insisted on that point. Don't have to be sorry. Think. You are bound to make mistakes, bacha. Everyone does make mistakes. I have made many stupid mistakes in my life. Even in class, I make mistakes sometimes. It's not about making mistakes that I'm concerned about. It's about not learning from that mistake that I'm concerned about. If you keep on doing the same mistake again and again, that is the problem. Doing a mistake is not the problem. No, we are all bound to do mistakes. We'll all make mistakes in our lives. We cannot avoid making mistakes in our life because we are trying something new. We will be making mistakes in our life. Don't worry about the mistakes, but don't repeat the same mistakes again. If you are always giving me the answer in terms of unknown quantities, okay, once it is okay. Twice, okay, I can still understand. But if you are repeatedly giving me the answer in terms of unknown quantities, that means you have not understood the question. That is wrong. If you're giving me the wrong dimensions, once it's okay. Twice is okay, but if you keep on doing it, that means you have not understood it. That is the problem. Anyone with an answer? I hope I am audible and visible to all of you. No one has the answer for velocity at point B. It is a very simple question, yaar. No question in this chapter is a difficult one, bacha. All are pretty straightforward questions. Trust me on this. Please give me an answer for velocity at point B. I'm expecting this answer from you guys. I'm expecting this answer. Don't let me down. Velocity at point B. No one has the answer. This is very sad for me to see this. If you cannot tell me the answer, okay. Okay, not a problem. I will solve it. So how do I solve it? Can anyone tell me what is the process of getting the velocity at point B? How will I get the velocity at point B? How will I get the velocity at point B? I'll have to apply what? I have to find out the value of this velocity. How will I do it? I'll have to apply. No one knows what I need to apply. Is everyone in the class, bacha? No one knows how to solve this question. No one would like to tell me how to solve this question. Okay. We have to apply law of conservation of mechanical energy, LOCME, from A to B. I have to apply LOCME from A to B very simply. That's it. What are the energies at point A? And what are the energies at point B? At point A, it only has two types of energies, potential energy and kinetic energy. Now, even at point A and at point B, spring potential energies are zero. Spring potential energies are zero. So let us not talk about spring potential energy. Let us only talk about gravitational potential energies. At point B, at point A, it has gravitational potential energies at both these points. Spring potential energies are zero because spring is not there. At point A, spring is not there. At point B, spring is there, but compression is zero. So in both the cases, spring potential energy is zero. Do we understand this? Can I have raised hand that we understand this? That at both the points, spring potential energy is zero. Let us not bother about that. Let us only think about gravitational potential energy. Now, the mistake that you would be making, most of you probably, and that is why you are getting different answers, is that you are taking gravitational potential energy of point C as zero, and then probably in calculations you are making mistake. You can take the gravitational potential energy at point C also as zero. But why? I have to apply LOCME from A to B. I have to apply LOCME from A to B. Why should I bring point C? Why should I bring point C into the picture? I should not bring point C into the picture at all. I can, as I said, I can call gravitational potential energy of any point as zero. For this particular case, I can call the gravitational potential energy of point B as zero. If gravitational potential energy of point B becomes zero, gravitational potential energy of point A becomes mg into h. Understand that? I repeat it again. If the gravitational potential energy of point B is taken as zero, gravitational potential energy of point A becomes mgh. Now you will say, sir, why you have changed it? Even if you don't change it, Even if you keep the gravitational potential energy of C as 0, this much energy, which I'm going to mark in pink, this much of energy, which is gravitational potential energy, will be same for both. It will also be added for point B. It will also be added for point A. Effectively, both will get cancelled out. So there is no point of calling gravitational potential energy of point C as 0. I can simply call gravitational potential energy of point B as 0. Do we understand this? Basically, when we are talking about gravitational potential energy, the only thing that matters is the difference between the 2 points. How much is the difference? At point B and at point A, what is the difference? The difference is the gravitational potential energy. So basically, gravitational potential energy of point A becomes mgh. Do we all understand this? Can I have some raise hand that we understand this? That is the gravitational potential energy of point A plus 0, which is the kinetic energy of point A. This does not have any velocity. It is at rest. So gravitational potential energy is mgh. Kinetic energy is 0. When I come at point B, gravitational potential energy is 0 because I've taken this as my base point. The kinetic energy is half mv squared, which most of you have forgotten. Viney told me this answer, which is the answer for energy, bicha. It is not the answer for velocity. This potential energy is equal to this kinetic energy. When I solve this question, when I solve this equation, I will get the value of V, and the value of V is simply root over 2gh. Now you look at it is coming in terms of G and H. G is known, H is known. So one criteria is fulfilled. Second, if I check the dimension of G into H, 2 does not have any dimension. If I take the root of that, it will be same as the dimension of velocity. So the dimension is correct. It is coming in terms of known quantities. It is correct. The answer is correct. That is how you check your answer. Someone was asking me, I think, Hannah, so how do I check my answers? This is the way that you check your answers. First criteria, it must come in terms of known quantities. Whatever quantities are known, only those quantities should come in the answer. Number two, you check the dimensions of the answer. If the dimensions of the answer are same as whatever it is asked, 99% your answers would be correct. Am I clear with this question? Can I have some reason that we understand this? Now I have to ask you one question. Why were you not able to get the velocity of point B? What was so difficult in this question? Can anyone tell me? Sir, this is the reason I could not get the velocity of point B. What was the problem in this question? We have done this question so many times. Don't you forget? We had released a block from height h, and then we had found out what is the velocity with which it hits the ground. Same question. We have done it so many times. If after doing it so many times you are not able to do it, that is not a good sign. I'm very depressed that you cannot find out the velocity of point B. That is a very depressing sign. I'm not very happy with that. Can anyone tell me why were you not able to solve this question? I will ask you all to unmute yourself, and everyone will tell me, sir, what was the problem in this question. ये क्या हुआ? Okay. So starting from Rahul. Rahul, you can unmute yourself. Tell me why you were not able to solve this question. Rahul, Ajay, Satya, Charita, Teja. Tell me why we are not able to solve the question. Deepak, Tejasvi, speak up. Sainath, Manasa, Swati, Harshita, Vahini, Vijay. Tell me the reason why you were not able to solve this question. You can all unmute yourself. I've allowed you to unmute yourself. Yes, Manasa, tell me. What was the problem? If I don't understand the problem, I would not be able to give you a solution. Tell me what was the problem. No one had any problem. If you can't speak up, you can write it in the chat, not a problem. What was the problem in solving this question? Anyone? I'm audible and visible to all of you. Well, no one wants to speak. Okay, I can understand that. Anyways, please note down this question and we will move ahead. I'll give you a minute to note this question down. Hannah, at point B, spring potential energy is 0. Spring is it in its natural length. Spring potential energy is 0. I didn't tell you? Spring potential energy is 0. If the spring is not compressed, if the spring is not extended, the spring potential energy is 0. Please remember that. Okay, Hanak has told me his mistake. Hanak, okay, good, not a problem. We are all bound to make mistakes. Everyone will make mistakes. The only thing is, if you can tell me your mistake, I would be able to correct it. If you don't tell me your mistake, I won't be able to correct it. And that is a problem. What about others? Anyone would like to say? No one? Not a problem. Please note this question down. And we are done with this law of conservation of mechanical energy. What I'm going to do is give you some homework that you will have to try at home. And what is the homework? Yes, but someone wants to speak. Who is this? Anak, you want to say something? Okay. I'll give you some questions to solve. And please note down those questions. So I hope that you have this sheet that I have already sent to you. This is your class notes. This is your sheet that you're supposed to have. So you have to solve this problem, which is problem number 58. Actually, you can start from the previous problem, problem number 57, but at least you have to solve this problem number 58 at home. Problem number 58. I hope you are noting it down, everyone. Problem number 58. Then it is problem number 59, based on law of conservation of mechanical energy and work energy theorem. Problem number 58, problem number 59. All problems are there with the solution, so you can try the problem and then you can see the solution. The next one is problem number 60, 58, 59, 60. Simple problems, no complications. Problem number 61 and 62. So all these problems you have to solve before coming to the next class. 58 till 63, till this heading of power, you have this problem, problem number 63. So from 58 to 63, 6 problems, you are supposed to do it at home and then come to the next class. Can you all do this? Can I have some raise hand that we'll do it, sir? Raise hands from everyone. Only 4 people have raised hand. That is not good. Vaini, Tarun, Harshita, Satvika, Sai, Sai Darshak, Reddy, Yashwant, Kevin. Will you all be trying the problems at home? All these are solved problems. You have that sheet with you, I hope. Solve these problems at home. If you have any problem, we'll discuss it in the next class. Please study beta. And if there's any problem, please ask me. I'm always there to help you out. And study hard. You are at home, enjoy your home food, but also study hard. This is the time to study. You can have just everything later on in your life. So I'll end this class on this note. In the next class, what we are going to do is we are going to introduce the concept of power. If you can read this small part that is given in your notes for power, it will be easier for you to understand the next class. So I leave that to you. 6 questions and understand the concept of power. We will meet in the next class. I hope you have enjoyed this class. We are back onto online form, and I hope you are liking the class as well as in the offline platform. I hope we can make it more better with your participation. That was the first class. I hope we can all participate more in the class and make it more interactive. On that note, I'll wind off this class. If there's anything that you can want to ask, please ask. I'm there. Take care. Bye bye.